Welcome back to Pre-AP Algebra 2. This is your last official kind of new material in the Trig unit. We are going to have just a quick little review session next time. And then next week you guys are going to be doing the Tarzan activity, which again is one of those world's longest story problems. Dealing with trig, but again, not new material. So today we are going to be covering inverse trig functions. So what happens when you reflect a trig function across the line y equals x? What happens when you swap inputs and outputs, switch x and y? What happens when you undo a trig function? We have taken the inverse of several functions over the course of the year. Some of our most memorable, if you think about the inverse of an exponential function, 2 to the x power, and I reflect that over the line y equals x, that will give us a logarithm function, log base 2 of x. That would be one of them. Another memorable one would be quadratics. So here's x squared. And once again, if I reflect x squared over that line y equals x, I will end up with a sideways parabola. Inverse of up is right. And again, we restricted the domain so that we are only looking at one branch of that at a time. And our most common branch would be your positive branch. Inverse of x squared, of course, is there's your square root of x function. We did the same thing with cubic, x to the 1/3. Anyway, these are our two most famous inverse functions for now. So we're going to do the same thing with inverse trig functions. We are going to invert sine, cosine, and tangent and do a couple simple transformations on those. So I'm going to start with f of theta is sine of theta. All right, let's start here. So let's start with the parent, and then let's see what happens when we invert things and what we need to do. So if I look at this function, we've been working on these for a couple days, so I'm just going to make a kind of a small sketch. I'm going to make it pretty quick. So there's my 2 pi over 2, 3 pi over 2. Here's my 1s. All right, so if I think about sine, I know sine unfolds through the unit circle from 0 to 0. Remember, again, we're looking at those y values. So my y value on the unit circle starts at 0 and unfolds all the way. In fact, that unit circle is going to be a little bit important here to us moving forward. So I'm going to think about the unit circle for a second. We know that the sine at 0 is 0. And as we move into pi over 2, our sine is going to increase that whole time all the way to 1. Oh, that's terrible. Okay, so you just make it thicker. Okay, so we know that that y value, as I'm traveling, this y value is increasing, all the way to 1. The same thing's happening here. Okay, so I'm going to stick with that for now. As I think about this keeps going all the way to 4 pi. And then it can also, of course, come back in this direction all the way from negative 2 pi. Where is it? There it is. All the way from negative 2 pi. Okay, so this is my continuous function all the way until forever, whatever my domain is restricted. Okay, so if I want to invert this function, one of the easiest ways to invert a function is going to be to use a table. So if I think about this function is unfolding horizontally. What's the inverse of horizontal? Vertical. So again, if you think about reflecting, my inverse function is going to be vertical, but if you are not spatially minded, as I can technically be challenged sometimes, I'm going to use a quick little table. So theta and sine theta. If I just go through my unit circle, 0, I'm just going to state my inputs, pi over 2, pi, 3 pi over 2, 2 pi. All right, so here's my parent points. At 0, sine of theta is 0. At pi over 2, I'm up at 1. Then I'm back down to 0, negative 1, back up to 0. All right, so there's my parent table. To create an inverse, let's swap the inputs and the outputs. So now I'm going to create my inverse function, which means my inputs of zeros, ones, and negative ones. Sorry, my outputs are going to become my inputs. That's a positive 1. And my old inputs become my new outputs. So now all of a sudden, my radians are my outputs. Okay, and let's see what this is going to look like now. So here's my original sine function. Now I'm going to graph my inverse sine function. We already kind of know what to expect. Instead of traveling up and down and up and down, my function is going to be traveling left and right and left and right. Instead of unfolding horizontally, my function is going to unfold vertically. So let's take a little look here. So I'm going to begin now. This time when I set this up, my 1s used to be my vertical. So now I'm going to set up my 1s as my horizontal. My radians used to be my horizontal. So now my radians are going to be my vertical. Here's 2 pi. I, of course, can go up to 4 pi. So here's pi. Pi over 2, 3 pi over 2. All right, and so on and so forth, infinitely. So if I just look at the parent function here, I'm going to follow these because I'm just not smart enough. So here's 0, 0. The next one is going to be, I'm going to travel right 1 and up pi over 2, over 0, and up pi. So if you look at the symmetry here with your inverses, 0, 0. This one went right pi over 2. Inverse of right is up. So as this travels up to 1, the inverse of up to 1, of course, is right to 1, which is really pretty cool, I think. So I'm going to travel this way. And as it travels down to pi, inverse of down is left, which is pretty cool. This one went down to -1, which means inverse of down is going to be left. And then this whole thing is just going to continue all that way. And then we can continue this way. Whoa, getting a little goofy. All the way on to forever. Okay, so my old parent function's right here, my new parent function's right here. And as you can see, all things have been inverted, dimension, inputs and outputs, horizontal and vertical. So then this begs the question, okay, so who's my parent inverse function? My parent regular function is right here. Okay, well, does that mean that this segment is also my parent inverse function? Some of you should be saying, no, 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 no. That is not going to work. Why is that not going to work? Well, it's not going to work because this is not a function. Fail, 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 fail. You're going to be failing the vertical line test here. Oh, okay, well, mathematicians still would like to study this as an inverse function. So then you might say to yourself, okay, well, let's only study from 0 to pi. Well, okay, wait, nope, that still is going to fail. So what we're going to do is we're going to restrict this domain, much like we do with quadratics. We're going to restrict the domain, as we've talked about before with tangent. Mathematicians always choose to surround the origin if we can. We also would like to include not only positives, but also negative values. So what mathematicians do is they say, okay, then, we are only going to study this piece, this tiny little piece of our inverse trig function. So this is -pi over 2. So we are only going to study this piece from 0 to pi over 2. And then we're actually going to go backwards to get some negative y values. And we're actually going to go backwards to -pi over 2 so that we can make sure that we're also studying these negative y values. Or if you look at the original, here's your negative y values. Here's your inverse, negative y values become negative x values. And then here's your positive values. So this is the little piece that we are going to study moving forward into inverse sine. So let's make some sense of this. So we've got f of theta, inverse sine of theta. If you want to use a sticky note for this, go for it. I'm just going to use some highlighters here. Moving forward in your mathematical life, you might also see this as arc sine of theta. Means the exact same thing as sine inverse or inverse sine theta. We choose inverse sine theta as much as possible. So what this is actually going to look at, I'm going to take this tiny little gummy worm. That's what my kids called it last year. And I'm just going to make it a little larger so that you know what piece we're studying. I'm going to set up my horizontal first. So I'm going to go from 1 back to -1. Of course, it's going to be the inverse of your original. The piece that we are going to choose to restrict is going to be, I'm going to extend this a little bit. Let's make it pi over 2 to negative pi over 2. And then this piece, we know that it's going to grow to the right. And then it's going to go to the, ooh, can make that a little curvier. Okay, there's my piece. My domain that I'm going to use for this parent function, my domain is going to be, where am I going? I'm going to be going from -1 to 1. Inclusive, it exists at both -1 and 1. My range for this particular function is going from negative pi over 2 to pi over 2. Okay, so here's the important pieces. Sticky note it or just highlight it or whatever. But after we went through this whole swapping inputs and outputs, I'm going horizontally, now I'm going vertically. Then we restricted the domain. This is what it all ends up looking like. And there is your inverse sine. Okay, so using the same kind of rules of mathematics now, let's unfold cosine and let's invert cosine and see what happens there. Okay, so if I inverse cosine, I think that I'm going to have enough room. Maybe not. Maybe I'll start fresh. All right, I'm going to need a new sheet of paper here. Okay, so for cosine, sorry, I'm going to go back to the parent. So here we are with our cosine. So let's call this one f of x. Why not? You can call it anything you want. You can call it f of snowflake for all I care. It's still snowing here on April 17th. All right, so let's look at f of x equals cosine of x. All right, first thing I want to do before I invert anything is go back to that original parent that you guys are getting used to using. Inverse cosine is going to go from 1 to -1. Again, this is mapping that unit circle. Going out to 2 pi. Okay. If I think about that unit circle, which I like to do once in a while, just make sure I'm keeping it real and I know where this is all coming from. Remember, the cosine, my cosine values start at 1. And as I travel up to pi over 2, as I travel, my x values are getting smaller and smaller and smaller as I'm creating this circle piece. And my x values are actually traveling to 0. So on this one, if I'm just looking at those x values, my first x value goes all the way out there to 1. So here's my first value. If I'm plotting it, my input is 0, my output is 1. And now they're going to get smaller and smaller and smaller and smaller and smaller and smaller as I travel horizontally all the way until that 0. Then as I travel to -1, so here's my positives. Then as I travel out here to pi, now my x values are going to start getting even more negative, even smaller as I travel all the way out there. So they're going to get more negative, more negative, more negative, all the way down. So I'm going more negative, more negative, more negative, more negative, more negative, all the way down to -1. So just to remind you where this is coming from, where this curve comes from, it's all those x values on that unit circle. Okay, so again, the pattern repeats as we increase back again. There we go. And of course, this continues infinitely until we restrict something. All right, so let's invert this whole thing. I don't think we need a table this time because you guys are so freaking brilliant all the time. So let's see about this. My 1s become my horizontal values. My radians, as they travel right forever, they will now be traveling up forever. So here's my 2 pi, pi over 2, 3 pi over 2. And then, of course, you can go all the way up to 4 pi, and we can go all the way back to negative 2 pi. Okay, so let's try to create this. So this value used to be 0, 1, which means now I'm out here. Instead of being up 1, I'm going to be right 1. Instead of being right 0, sorry, instead of being right 1, instead of being right pi over 2, geez, right pi over 2 is going to become up pi over 2. I'm losing it. Okay, so we're traveling this way. This was traveling down, which means this piece is traveling up like this. All right, this last value here used to be right pi down 1. So now if I invert these, it'll be left 1 up pi. And now I can start to see my cosine. So there's going to be my cosine. And of course, I could continue this cosine all the way to 4 pi. And of course, I could continue this more or less there. All right, so infinitely horizontal, infinitely vertical. And of course, now mathematicians have an issue. Oh my gosh. I would like to include positives and negatives, but I need to restrict my situation here. All right, well, if you think about what we did, what mathematicians did with sine, they chose negative pi over 2 to pi over 2, but that's going to be an issue in terms of a function. And remember, mathematicians want to include positives and negatives. Well, right here, you can see, according to my unit circle, here were my positive values. Here are my negative values. So what mathematicians are going to do is they are going to restrict your inverse cosine to this tiny little slice. So now as I make my f of x equals inverse cosine of x, here's my important piece, or arc cosine, whichever is presented to you. So as I make this my parent, I'm going 1s, negative 1s, and I'm just pulling out this slice right here. So if I pull out that little slice, I'm going to make it a little bigger. Pi and pi over 2. We are only going to be looking at this part of the unit circle, and we are only going to include this slice as we move forward. Oh, I got to do domain and range. All right, domain, negative 1 to 1. Range. Range on this one for the parent is going to be going from 0 to pi. So we're including the top part of our unit circle because we have cosine again as our x's. So I have positive x's and negative x's. Looks a little different than sine. Okay, there's my parent cosine. Last but not least, everyone's favorite, tangent. Now, as challenging as tangent may seem typically because of all those asymptotes and the discontinuous nature of the function, it's actually one of your easier invert functions or inverse functions. So if I look back to my parent for tangent, remember tangent includes that origin. So if we only look at one branch of tangent, we're looking from negative pi over 2 to pi over 2, and we're including those fourths because that's where we get our 1s. So up 1, getting a little squishy, down 1. Here's my vertical asymptotes. Okay, so as I build tangent, I've got my 0, 0, my pi over 4, negative pi over 4, and this will travel quicker and quicker and quicker towards my asymptote. And then that direction. Perfect. Okie dokie. So now what we're going to do is now if I'm going to create this inverse, what is the inverse of vertical asymptotes? I can hear my alarm going off. I have a math Zoom meeting. Hang on one second. Let me turn it on. Alrighty, so if I were to invert this whole thing, this function travels vertically, which means the inverse function is going to travel horizontally. So I'm just going to go ahead and make this one right away here. Okay, I'm going to start with my asymptotes. My old horizontal used to be my radians, so that will be my new vertical. So I've got my pi over 4, pi over 2, negative pi over 4, negative pi over 2. All right, so my old asymptotes were vertical. My new asymptotes for my inverse are going to be horizontal. This branch used to travel up forever, which means the inverse of that is going to be right forever. Let me get my ones in here. Okay, so this branch used to travel up forever, which means my new branch is going to be traveling right forever. This branch used to travel down towards my asymptote, which means this one is going to be traveling left towards my asymptote. And just like that, there's your inverse tangent. I find inverse tangent to be a little bit easier. Domain and range on this one look a little different though. Domain for my inverse function is going to be my infinities. So I'm traveling from negative infinity to positive infinity. And my range on this one is going to be negative pi over 2 to pi over 2, but that's going to be not inclusive due to those asymptotes, which is pretty cool. All right, there's your 3 inverse functions. Now, of course, what we can do, and what you guys will be doing, is you'll be transforming these inverse functions to see what happens if we move them around and scale change them and translate them and shift them. So I still have a couple minutes left here. I'm going to do a little bit of that with you, keeping my notes sheets handy because I am new at this and I want to make sure that I'm looking at my parent functions correctly. So I'll get to 1, maybe 2 examples. We'll see if we have enough time. And then you'll have a couple to practice. So here's my example 1. Example 1 is going to be f of x is 2 times the inverse sine of x minus 1. Okay, so I am going to be thinking about my inverse sine function. I'm looking back here. There's my inverse sine function. In fact, I might just keep it here so that I can see what exactly is going to go on. So let's make our way through our transformations. I've got this multiplier on the outside, which means it's going to affect my outputs. And instead of growing to pi over 2 and negative pi over 2, this is going to grow twice that vertical distance. So twice this is going to be pi and negative pi. So I already know that we are going to have a vertical scale change by a factor of 2. And I can tell that my inputs, I have been translating inside input inverse. This is going to be a horizontal translation, right 1. Now we're not in the radians, we're in the real numbers here, which means we don't need to call it a phase shift. We can just call it a horizontal translation to the right 1. All right, so I've got my eye on my parent, and now I'm just trying to create this as best as possible and then think about the domain and range. All right, so there's my new axis. I'm going to kind of set up my domain and my range here. These we decided instead of growing to just pi over 2 or half a pi, this is actually going to grow to pi and also down to negative pi. So the whole thing is stretched quicker by a factor of 2. So that will be my range. And then this whole thing is going to move to the right 1. So before I do anything, just because I'm new at this and I'm not amazing yet, I'm going to get my -1 there and my 1. This is where the whole thing used to be. So sometimes what I like to do, especially if I'm not going to use a table, is I like to just do one thing at a time. So let's just do that translation. And I'm going to start with -1. I'm going to change color here. So I'm going to start with -1 all the way down to pi. So that's where my point would be. Then 0, 0 doesn't change because 0 times 2 is nothing. And this one, instead of being right 1 up pi over 2, I'm going to go all the way up to pi. So this is going to be a much more vertically stretched function. But now these points are actually going to move right 1. So this point is actually going to move here. This point is actually going to move here. And this point that used to be right 1 is actually going to be here. Or well, where is that value? It's right there at 2. So sometimes that's what I like to do as well. It makes it a little bit easier for me, especially if I'm new at a function. So maintain the integrity of that shape. There's your little piece. And that's all we got. Domain. Once again, let's see. We're looking at our x's. So our x's, I could do a little x equals inside domain. We're going from 0 all the way to 2, inclusive. And my range, which is my f of x, is going to be from -pi to pi. Cool. And that's it. Okay. Good luck on these tonight. It looks like we've taken 2 of your usual homework problems and turned them into extensions. You're going to be working on 13.5, just graphing these little parent functions, moving them around. See how you do. We're going to have Zoom sessions tomorrow as usual. Come on and get some help if you need it. Alrighty, talk to you later. Bye.